Welcome to the Science of Hockey, the podcast where we break down the science behind ice hockey. I'm the analyst, your host, and every week we explore the data, research, and evidence that shape how we play, train, and understand the game of hockey. From biomechanics to performance psychology, we take you beyond the rink and into the research lab, giving you insights that go beyond hearsay and into what really makes the difference on the ice. Whether you're a player, a coach, a parent, or just someone passionate about the sport, we're here to bring you scientifically backed information in a language that's friendly and easy to understand. So grab your skates and let's dive into the science of hockey. Welcome to the Science of Hockey, where innovation meets the rink. I'm your host, the analyst. In today's episode, we explore groundbreaking research on flexible ice hockey boards and their potential to reduce injuries. Stay tuned as we unpack crash test dummy studies and the science behind safer gameplay.
Hey everyone, and welcome back to the Deep Dive. Looks like we've got a lot of hockey fans out there, especially interested in player safety.
Yeah, always a hot topic.
Absolutely, and we've got some really interesting research to dig into today, all about those flexible hockey boards.
Oh, right, yeah, the ones that are supposed to be, safer.
Exactly. We're diving into a scientific paper today that's trying to figure out if they actually reduce player injuries.
Interesting.
It's called, get this, Crash Test Dummy and Pendulum Impact Tests of Ice Hockey Boards. Greater displacement does not reduce impact. Kind of mouthful, but it gets right to the point. The idea, right, is that instead of those rigid boards we're used to, these flexible ones would give a little.
Yeah, like a cushion, kind of.
Exactly. Sounds good in theory, less force on the body, but the study found some pretty surprising stuff. It's not as simple as more flex equals less injury.
Well, that's why we got to look into it, right?
For sure.
Right.
So before we get into the nitty-gritty, let's talk about why we're even talking about new boards in the first place.
Right, good point.
What's the problem with the ones they use now?
Well, hockey, it's fast, it's physical, and those boards around the rink, they're a part of the game.
Yeah, for better or worse.
Unfortunately, a lot of injuries happen because of contact with those boards.
A lot. Like how many are we talking?
Studies have shown it could be anywhere from 20% to 40% of all hockey injuries. That's a big chunk.
Wow. Yeah, that is a lot. And we're not just talking bumps and bruises here, are we?
Oh, no, definitely not. We're talking cuts, fractures, sprains, concussions, the whole gamut.
Serious stuff.
And that's why, of course, researchers are looking for ways to, make things safer, but without changing how the game's played, of course.
Yeah, got to keep the essence of hockey. So these flexible boards, they're an attempt to do just that. How did the researchers test them?
They used a couple of methods. One was a pendulum test.
Okay.
Basically, they swung a 60-kilogram weight at the boards to see what happened.
I'm picturing like a giant wrecking ball.
Pretty much.
What were they measuring exactly?
A few key things. One was displacement, so how much the board moved when the weight hit it. Then there was stiffness.
So like how much it resists bending.
Exactly. And then there's this thing called effective mass.
Effective mass, huh? That one sounds a little,
complicated.
Yeah, a little bit.
It's basically a way to measure, how much of the board's weight a player actually experiences during impact.
Okay.
So think of it this way. If you run into something really light, it's not going to have the same impact as running into something super heavy, even if they both move back the same distance.
Right. That makes sense.
So a lower effective mass means less force is being transferred to the player, which should make it safer.
Got it. So besides the pendulum, they also use those crash test dummies, right?
They did. Full-on crash test dummies, like the ones they use in car safety tests.
Wow, that's commitment to the research.
Right. They slid the dummy into the boards at almost 5 meters per second. Pretty standard hockey speed.
So simulating a real player hitting the boards.
As close as you can get. They used different boards, too.
Oh, like different types.
Yeah, they tested 6 different designs. They had one standard rigid board, the kind they use now, and then 5 different flexible ones.
Okay, so different designs for the flexible ones.
Yep, each a little different.
All right, so now the moment of truth. Did the flexible boards actually make a difference?
Okay, so here's the interesting part. The flexible boards, they definitely moved a lot more than the standard board.
Okay, so they had that give.
Oh, yeah, some of them moved 4 times as much.
Wow, that's got to be good, right?
You'd think so, but here's the catch. That greater displacement, the give, didn't actually always mean a lower risk of injury.
Wait, really?
Yeah, some of those flexible boards that moved a lot, They actually had similar impact forces on the dummy as others that didn't move as much.
Huh. So more give doesn't necessarily equal a softer hit.
Exactly. And that's because the energy absorption, like how much energy the board actually absorbed, was pretty similar across all the boards, even the rigid one.
So it's not just about making the board bend.
Nope, it's way more complicated than that.
So what was the difference then between the flexible boards and the regular one?
Well, they found the key difference was in the stiffness and that effective mass we talked about.
Right.
The flexible boards were less stiff and had a lower effective mass, so they didn't transfer as much force to the dummy.
So even though the energy being absorbed was the same, the way it was transferred was different.
Yeah, think of it like this. Would you rather be slowly pushed back a long way or suddenly stopped short?
Ooh, I'd take the slow push any day.
Right. It might be the same amount of energy overall, but it feels totally different, and it affects your body differently.
That's a great way to put it. So it's not just about the give, it's about how the board gives.
Exactly. And there's another thing, too. The study found that the way those different boards hit the dummy, like the angle and point of contact, varied a lot.
Oh, I see. So even if the overall force is lower, it could be concentrated in a way that's like more dangerous.
Exactly. Like one board might hit you right in the chest and another might glance off your shoulder. Same force, but very different outcomes.
So just measuring the overall force doesn't tell the whole story.
Nope, gotta look at how the player's body is actually interacting with the board. And that's what makes this research so interesting.
Yeah, it's definitely got me thinking, this is fascinating stuff.
So yeah, it's not as simple as we thought. Huh.
Definitely more to it than just making the boards bendy.
Right, but that's what makes it exciting, right?
Oh, how so?
Well, because now we can start thinking about, like, smarter designs, you know? Boards that are actually better at protecting players, not just absorbing the impact.
Smarter boards. I like the sound of that. What do you mean?
Think about it. We could engineer boards that deflect the impact away from, like, the head and spine, the vulnerable areas.
Right, yeah, that makes sense.
We could use different materials or maybe strategically placed padding or even, like, active elements that react to the impact in real time.
Wait, active elements? Like the board actually responds when a player hits it.
Exactly. It might sound futuristic, but the tech is there. We could do it. That's why this research is so cool. It's pushing us to think outside the box, you know? Not just more padding, but something totally new.
So are we talking about a future where hockey is, like, safer, but still just as intense, just as exciting?
Exactly. We don't want to take away the physicality. That's part of what makes hockey great.
Right, yeah, it's a balance.
Finding that sweet spot, that's the goal. We want players to be able to, you know, give it their all without ending up with these long-term injuries that affect them later in life.
Yeah, nobody wants to see that. It's got to be about protecting the players. But this all brings up some interesting questions too, right?
It does. Like, okay, so we can make safer boards, but should we? Does it change the game too much? What about the cost of all this new technology? These are all things that leagues, players, even the fans are going to have to think about.
It's like uncharted territory almost.
Yeah, we've got this potential to make things safer, but we got to think about what that means. The good and the bad, you know?
So how do we even start to figure that out?
Honestly, we need to talk about it openly and honestly. We need everyone at the table. Scientists, engineers, players, coaches, even the fans. Everyone has a stake in this.
So it's got to be a collaborative effort to figure out these solutions.
Absolutely. It's about finding what works for everyone, what's best for the game.
Makes sense. You mentioned the cost of all this talk about smart boards and new tech. That's got to be expensive, right?
Yeah.
What about smaller leagues or community rinks? Can they afford that?
That's a good point. New technology, yeah, it usually costs more at first.
Right.
But, you know, that's how it goes. Eventually, things get cheaper as more people start using them.
It's like those flat screen TVs, right? Used to cost a fortune, now everyone has one.
Exactly. What's a luxury today, it'll be standard tomorrow. It's exciting to think about what's possible.
It is. It's like we're seeing a glimpse into the future of hockey. Maybe someday these boards would be able to, like, record the impact data in real time.
Oh, yeah, totally. Why not? Coaches and doctors could know exactly what happened right away.
Wow, that's wild. We're really going deep here.
We are. But let's bring it back to that research paper for a second. What stood out to you from this study?
For me, it was really realizing that it's not just about the give. It's about how that give translates to less force on the player and where that force goes.
Great point. And that's why we need to come up with better ways to test these boards. It's more than just how much they move.
And it's got to involve everyone in the process, right? players, equipment companies, the leagues.
Everyone. We all need to work together to make the game safer.
Couldn't agree more. I love that idea. This has been really eye-opening. But before we wrap up, I want to know, what do you hope our listeners take away from this deep dive?
I hope they come away feeling optimistic about the future of hockey. People are working on this, this research. It's just one example. We're using science and engineering to make things better. It's a process, but we're moving in the right direction.
It's not about finding the one perfect answer. It's about constantly improving.
That's it. And we can all be a part of that.
Awesome. Okay, we've covered a lot of ground today, from the technical stuff to the bigger picture. Before we move on, what are some ways our listeners could explore this more on their own? Any suggestions?
Yeah, there's a lot out there.
Right. Where do you even begin?
Well, one thing people can do is look into the specific boards being used right now.
Oh, yeah, like different brands and stuff.
Exactly. See what companies are already doing with, flexible elements in their designs. It's pretty cool to see the different approaches.
So do some digging into the actual boards out there. What else?
It's also a good idea to check out the safety rules different leagues and organizations are using. Like the NHL's done a lot with concussions and head injuries, right?
Yeah, they have.
Seeing what they're doing can give you a better idea of how the whole sport is, changing in terms of safety.
Makes sense. So we've got researching board designs, looking into the rules. Anything else?
Oh, yeah. For those who want to go even deeper, there's a whole world of sports science and engineering research out there.
Oh, right.
People are doing some really cool work on, like, the biomechanics of hockey, how the body moves and all that, and they're coming up with new ways to prevent injuries.
That's awesome. So keep an eye on the latest research, it sounds like. Great suggestions. But before we wrap up, you were talking earlier about how important it is to get everyone involved in this, scientists, engineers, players, even the fans. Why is that so important, especially in a sport like hockey? It's so physical, so much a part of the culture.
It's because hockey is more than just a game, right?
Yeah.
It's got this huge cultural impact, means something to so many people. So any changes we make, even if it's for safety, we got to do it carefully.
Right. We can't just throw out the things that make hockey hockey.
Exactly. It's about people's emotions, the traditions, all of that. We got to respect that.
I hadn't thought of it that way. That's a really good point. It's not just about the science.
It's about people. That's why it's got to be a group effort, No. Scientists, they know about the forces and the materials. Players, they know how the equipment actually feels, how it works on the ice. Coaches, they understand training, preventing injuries. And the fans, well, they're the ones who love the game.
They're the ones who keep it going.
Right, exactly. Everyone's got to have a say.
It's like we all have a piece of the puzzle.
I like that. And it's not just about finding a solution. It's about the right solution, the one that keeps the game intense, exciting, but also protects the players.
Makes sense. So collaboration is key. We've established that.
Yeah.
But how do we actually make that happen, get everyone on board?
Well, the big organizations like the International Ice Hockey Federation, the national leagues, they've got to take the lead.
Yeah.
They can set up ways for people to communicate, hold meetings, share research, that kind of thing. They can also work with the companies that make the equipment to develop standards and testing.
So create a system where everyone's talking, working together.
Exactly. That's how we're going to make hockey as safe as possible without losing what makes it great.
Yeah, that's the goal. It's kind of amazing to think about how much hockey's already changed. Right?
Well, yeah.
Helmets, visors, all these rules against dangerous hits.
Yeah.
It's come a long way.
It has. And that's because of people who cared enough to do something. The researchers, the people making the equipment, the players speaking up, the leagues making the rules, even the fans demanding a safer game. It all adds up.
Shows that it can be done, even in a sport like hockey. And it reminds us that, we all got to keep pushing for progress.
Couldn't agree more. We're not done yet. It's a journey.
This has been a fantastic deep dive. We learned about the boards, the science, all the things that go into player safety. But I think the biggest takeaway for me is that the future of hockey, it's in everyone's hands. We all got to work together to protect the game and the players.
Well said. It's been a pleasure talking about all this.
Likewise. And to everyone listening, thank you for joining us on the deep dive. Keep learning, keep asking questions, and let's make hockey the best it can be. Until next time, stay curious.
Thanks for tuning in to the Science of Hockey. If you enjoyed today's episode, make sure to share it with your friends, teammates, or anyone who loves hockey as much as you do. Don't forget to subscribe so you never miss an episode, and we'd love to hear from you. Leave a comment to let us know what you liked, what you'd like to hear next, or any questions you have. Your feedback helps us make the show even better. Until next time, keep your skates sharp, your mind open, and keep chasing the science behind the game.